Malviya. We are starting with the first experiment, that is the study of the CRO. This is block diagram of the CRO. Here we are able to watch that there are two channels denoted by the CH1 and the CH2. Okay, channel 1 is a representation of the Y, that is able to see here. We are able to see here because the Y is a representation of terminal where the signals are applied. Okay, so input coupling shown here means the input impedance should be very high to sense the signal and capture the signal completely. That is applied to the test signal denoted by the Y here. Okay, and for this signal, if we have the high value of the input, so that must be attenuated. So that's why we have the attenuation for the channel 1, right? Okay, is the input stage of the CRO must be very high. So that's why there is a pre-amplifier. The role of the pre-amplifier is to sense and capture the signal completely. So any of the signal which may have the very high amplitude must be attenuated first and then applied to the pre-amplifier. And if the signal has a very low amplitude, so this must be amplified with the help of the pre-amplifier. And if we properly capture, right, so the signal can be represented by the CRO. Okay, after it we have the intermediate amplifier denoted by the Y terminal here, right? And if you look at the channel 2 here, so if you are able to watch here channel 2, so what's happening here, the applied input signal is coupled to the vertical amplifier here, that is represented by the Y pre-amplifier here, as well as to the attenuator here, and the signal is connected to the diode switching. So the role of the diode switching is to send the signal one by one with the lowest delay to the final amplifier denoted by the last block diagram here, right? And at the last stage, the output of the final amplifier is connected to the Y plates of our CRO. Right. So if you look at the channel 2, similar things can be seen here, and that's why this is the dual slope or dual progress CRO. Right. There are many types of the CROs are available in the market. Single channel, dual channel with the dual trace, dual channel CRO with the dual wave. Right. So we are using here dual channel. Okay. Now if we go to the horizontal section. Okay, earlier we discussed about the vertical section of our nucleus CRO, right? Now, to connect the signal for the synchronization, we have to use horizontal section here. And if we look at the horizontal section here, so every coming input to the channel 1 or to the channel 2, right, is used for the synchronization purpose. But if you look at the channel 1, that is denoted in bracket by the Y, so that means the base signal is connected to the vertical amplifier section. This signal is connected to the Y plates, and that's why Y is shown here. If you look at the channel 2, that is denoted by the X here. Right? That means the signal connected to the channel 2 will go to the horizontal section, right? So here, if you look at this part here, so there is no change between the channel 1 representation and channel 2 representation here. So where is the major change in case of the applied signal or for the synchronization? So look at the trigger amplifier here. That is Schmitt trigger is connected here, right? The role of the Schmitt trigger is to provide the backband signal, right? So Schmitt trigger is coupled here. According to the need, we can invert the signal. We can apply this to the comparator so that the signal for the proper batch can be generated here. So backband signal, baseband. This is a time-based signal. So this time-based signal is nothing. That is a sweep generator signal. Right. So sweep signal is applied here, and the sweep signal, the selection behind the sweep signal is that it is a varying amplitude, right, and in one direction only. So that's why the sweeps are used for the synchronization purpose. And these generated sweeps are connected to the horizontal amplifier and finally connected to the X plate. So X plates of the CRO is a representation of the output of the horizontal amplifier to the horizontal plates, right? So we have two sets of the plates in CRT. One is a particular set of the plate denoted by the YY dash, and another set of the plate is denoted by the XX dash, right? So the sections from the vertical direction, from the horizontal direction will pass to the Y plates and X plates. Okay, so now if you look at the remaining part of our CRO demonstration kit, so what's available here? The input test signal. Okay, this is shown here. Input test signal is coming to the component tester, as well as the same signal is coming here for the trigger purpose. Right. So any of the applied signal that may be connected to the channel 1 or channel 2 is now applied for the triggering operation, so that the proper time base can be generated and can be applied to the XX plates. Right. If you look at this block diagram of the CRO that we are using for the study here in our laboratory, so we can find here that we have the calibration. If we want to calibrate, so calibrator is available here. Component test tester is available here. With the help of this component tester, you can measure the value of the restraints as well as the cap strength, right? But you must have the prior knowledge about it. What should be the shape, observable shape on the CRT screen, right? Different power supplies are available here, as we discussed earlier, virtually here the positive and the negative power supplies are available. So we must have the variable transformer as well as the variable power supply section, so that we can produce the different quantities of the applied signal. So you are watching here -12, +5, 24 volt, 145 volt, 250, 250, 260 volts, etc. Similarly, we have the extreme high tension here, denoted by the EHT, right? So the role of the extreme high tension is to provide the very high value of the voltage. When a signal, an electron passes through the X brakes in CRT, then it requires a very high value of the voltage, because it has to cover the vertical and the horizontal direction of the CRT. So that's why 10 kilovolt of the approximate voltage is required. So that is generated with the help of the extreme high tension. And then finally, this is connected to the neck of the CRT. So that the electron must gain the very high value of the aspiration and can cover the desired part of the CRT screen. Okay, now look at the different sections which are available in the circuit form. So let us start with the Y input attenuator here. And if you observe this attenuator, so we can find here that the various combination of the capacitor and the resistors are available here. So the attenuation of different values like the 5 dB, 10 dB, 15 dB, 20 dB, 30 dB can be obtained with the help of this RC attenuator, right? So you are able to watch here the different values of the capacitor, fixed capacitor, variable capacitor, right? So that's why you have the different values of the attenuation, and the attenuation can be seen on the front panel with the help of. So that section of the attenuation can be represented with the help of the hidden part of the volts per division here, right? So you are able to watch here the volts per division for the channel 1 here denoted by the Y here, as well as the volts per division denoted by the X here, right, by the channel 2, right? So this volts per division, right, it used to show the change in the volts with respect to the division, and that can be observed. This volts per division means changes the value with the vertical and the horizontal direction on the CRT screen. So the CRT screen is nothing, that is the graticule. So we discussed about 3 types of graticules. Number 1 is the internal graticule, number 2 is the vertical graticule, and number 3 is the external graticule, right? So we can check here that the graticule is nothing, that is combination of the vertical scale and the horizontal scale. So with the help of this graticule, we can find out the measurements of the voltage and the frequency, right? So as we discussed earlier, like the CRO is an electrostatic device, right? So because of the electrostatic device, any of the signal that we apply to the CRO will be the voltage only. So any quantity that may be the electrical or non-electrical in nature, that must be given to the CRO only in terms of the voltage only. So any non-electrical quantity must be converted into the electrical quantity and only in voltage, right? But there is no foundation that you are unable to measure the value of the current. But if you want to measure the value of the current, so in that case, the current must be passed through a resistor, and the drop across the resistor is observed, so that the voltage can be applied to the CRO, right? Now let's look at the another section here, intermediate amplifier here. So whatever you studied in your basic electronics as well as in analog electronics, including both the subject of the circuits and the operation amplifiers. So you have these are the transistor, BJTs are available here, as well as the different ICs are available here. So intermediate stage is used to control the gain and the input impedance also. So this complete section is available in the CRO in the PCB form, right? So we go through the PCB withdrawal, right? So if you look at any of the section, multiple transistors are available here, right? And what is the role of the intermediate stage? Just to enhance the value of the gain, provide a proper gain, as well as control the input impedance, right? So these are the things are here, as well as if you look at the vertical section, because vertical section is a representation of the Y here, and the vertical section is responsible for the proper bandwidth as well as the gain. So these two parts are completed with the help of the vertical amplifier. Number 1, the gain is controlled, as well as the proper bandwidth can be watched on the CRT screen, right? So that's why the CROs are made for a proper frequency range, right? So you may have the CROs of 10 megahertz range, 20 megahertz range, 30 megahertz range, and depending on the particularly selected bandwidth, you have to pay the particular cost, right? So in this laboratory, we have different types of the CROs are available, and those CROs have the variable cost. One may have other 10,000 rupees, other may have the 20,000 rupees, third may have the 50,000 rupees. So depending on which type of CROs you are using in the lab, and the cost is responsible for a particular frequency range.